So I'm going to present a study that aimed to understand sleep physiology using a novel framework for the classification of sleep data. So currently, sleep states are categorized in 5 different stages using a set of rules from the AASM scoring system that is entirely based on the visual inspection of sleep time series. So scorers look for visual patterns in the data, notably characteristic rhythms in the EEG, or transient events like sleep spindles in N2. But this simplistic scoring method poses two main limitations. First, the time series that were selected for their visual properties rather than their biological relevance to sleep physiology. And also, because it's entirely based on visual inspection, only a few visible features are used to characterize the data, and we're probably overlooking a lot of information in the signals. So we developed a novel framework that overcomes these limitations in 3 main steps. We first extensively characterized EEG, EOG, and EMG time series by applying over 7,000 operations from a software called HETSA. So we applied those 7,000 operations systematically to full net recordings, and as a result you have each 30-second time series that is converted into one vector of 7,000 feature values. Then, as a next step, we organize this time series based on their similarity in feature values in a data-driven way, and then we assign each cluster to one of the 5 traditional sleep stages. So as a result, you have a data-driven structure of sleep that is organized after taking into account an extensive amount of the time series properties. So by comparing this novel structure with the traditional structure of sleep, we identified some interesting points of divergence. On this figure, you can see each time series that is organized by their sleep stage. So you have wake N1, N2, and N3 and REM. And within each traditional stage, you have groups of epochs that were assigned to different clusters by our framework, meaning that our framework identified distinct properties within individual stages. We focused a bit on N2, and we visualized N2 time series in low dimensional space. And in these 4 subjects, you can see a clear heterogeneity within N2 in terms of time series properties. And this is completely overlooked by traditional scoring. This heterogeneity was picked up by different novel features. So you have specific measures of the power spectrum, of the variance, of the distribution. We could, for example, discriminate N1 and REM using the slope of the linear fit to the power spectrum, which is a measure that has been recently defined as an indicator of the level of consciousness in sleep and anesthesia. So new insights into sleep physiology can be gained by applying those novel features. So in sum, our framework lays the groundwork for a data-driven exploration of sleep and represents a promising tool to identify potential substages that are not captured by visual inspection.